Greetings YouTubers, I'm Rick the Tech Enthusiast here with the next Elegoo lesson number 25, the serial monitor. In this lesson, we'll build on lesson 24 and use the serial monitor's input feature to control which LED gets turned on. So let's start building. We've used the serial monitor in past lessons and even used the serial monitor's input feature for the Morse code circuit we built in lesson 6. But here's Elegoo's official lesson on the topic. Now we're going to reuse lesson 24's circuit, so hopefully you still have it available. If not, please review lesson 24. As you can see, this is like lesson 24. We have the LEDs 0 through 7 over here with the resistors. We have the shift register right here. And we have the 3 wires for the DS, the latch clock and register clock. And then we have power and ground. This little Q0 jumper just kind of walks around the IC here, but it ends up to this little wire here that connects all the way over here. Interesting. Okay. As before, we'll load the recommended sketch provided in the tutorial. Go to the File menu item, select Open, and browse to where you saved the Elegoo files. Under your language, Code, under Lesson 25, the serial monitor, under the _serial _monitor folder, and open the _serial monitor.ino file. Now this is almost identical to lesson 24's tutorial sketch, so let's just cover the changes. The void setup now includes the serial begin statement to start the serial monitor. Then the while loop checks if the serial monitor is not ready. If it isn't, it'll just keep looping. This way, it just waits until the serial monitor is opened by the user and is ready. Once it's ready, it sends to the serial monitor the instructions to the user to enter a value from 0 through 7 or X to clear it. The void loop got a slight overhaul. It starts with an if statement to check the return value from the serial available function. Now the serial available function will return the number of bytes stored in the serial monitor's input buffer. In other words, as someone types something, each character is stored in the serial buffer as a single byte. The more characters, the more bytes. If that number is greater than 0, that statement becomes true. The next line, the serial monitor function returns a byte value from the serial buffer to the char ch. Now it checks the char ch if it is a number between 0 to 7. Recall that each character in the ASCII table corresponds to a numeric value. Here you can see that char 0 is decimal 48 and char 7 is decimal 55. So it's simple to compare the numeric values. If it holds true, the integer LED gets the difference of the char ch decimal value, subtracting the decimal value for the char 0, which is 48. This is an easy way of getting the simple integer from 0 through 7. Then we use the bit set function like we did in lesson 24 to set the targeted LED bit within the byte LEDs. Like before, it simply turns on or makes it a 1, the bit corresponding to the LED value. Then it calls the update shift register function to turn on the LEDs corresponding to the bits turned on. This is followed by the 2 serial monitor prints turned on LED and the decimal value LED. Next, it checks if the char ch was a lowercase letter x. If it was, set the variable LEDs to 0 and call the update shift register function, which will turn off all the LEDs. Then it sends a cleared to the serial monitor. Okay, let's upload the code and try it out. All right, we'll open up the serial monitor. And you can see it presents us the directions to enter the LED number 0 through 7 or X to clear. Let's go ahead and enter number or add a number 7, hit enter. As you can see, the 7th LED does turn on. Let's go ahead and hit 5. The 5th LED does turn on. That's from 0 through 7. Let's go ahead and do, let's do 3. All right, 3rd LED turns on. You can see that. Let's try 0 now. And you can see 0 does turn on. Excellent. Let's go ahead and hit X. And that is now cleared. You can see it turns off all the LEDs. Pretty easy. Let's try them all. Let's go 0, 1, 2, 3, 4, 5, 6, 7. Woo! X to clear. Fantastic. It works great. And just to show that this works this way, as I mentioned before, the reason why it works sort of backwards is this little least significant bit first command on the shift out register. If we change this to the most significant bit first, and then we upload that, now if we go to the serial monitor and we type in 0, you can see that the 0 is now way over on the left, and 7 is now way over on the right. And this time, the 7th bit does correspond to the Q7. Just thought I'd show you that little difference there. Well, that's it for this lesson. I know this one is kind of short, but I hope you've learned a little about providing input using the serial monitor. Also, you may want to revisit Lesson 6 and the tutorial for more information. If you like this sketch, be sure to let me know in the comments section below. I'll have additional links for other interesting videos and code for this project in the show notes below. Join me next time for Lesson 26, Photocell. If you like this video, don't forget to rate and subscribe. Thanks, and see you next time.